In this section, what we're going to do is we're going to combine the rules of probabilities and finding probabilities from the beginning of the chapter with the counting rules that we talked about in the most recent section. If we hop clear back to the beginning of the chapter in this book, we said that the probability of an event occurring is the number of ways that event can occur over the total number of things in the sample space. So if I were to flip a coin one time, I know there is one way out of two possible outcomes of flipping a head. Or maybe I flip the coin 3 times in a row. There was one way out of 8 possible ways. So 1/8 probability of flipping 3 heads in a row. And depending on what our event looked like, coming up with these sample spaces or the number of ways our event can occur, we had several different approaches. Okay, tree diagrams, making a list, that sort of thing. Again, we're going to be looking at counting rules to help us do our probabilities today. So in a company, there's 7 executives. We've got 4 women and 3 men. We're going to pick 3 to attend a management seminar. So it says 3 are selected to attend the management seminar. Now, if we're just thinking about the number of ways of choosing 3 people from the 7, and I used the word choose on purpose, it doesn't say that we are electing officers for this group, or we're selecting them to go one at a time in a certain order. We just need a group of 3 people out of the 7 that we're starting with. Okay, we know that the total, that'll be a combination that we'll be working with. Maybe I want to find the probability that when I select this committee of 3 people to go, that all 3 of them will be women. Okay, so if I want to find the probability of something happening, I have to figure out how many ways I can choose 3 women over how many total possible ways I can get 3 people. So maybe I'll write this on this example. Number of ways I can choose 3 women over the total number of ways I can choose 3 people. There's 2 O's in choose. 3 people. So what I have on top, I'm just making a group of a certain size. Those guys are going to be combinations. Excuse me. So we're starting with 4 women. And from those 4 women, I'm only going to select 3 of them. On the bottom, we want the total number of ways I can choose 3 people, which means out of the 7 people that I'm starting with, I'm choosing 3 of them. Now we know that 4 choose 3 is 4 factorial over 3 factorial 1 factorial. Okay, something I didn't say out loud last time, but 0 factorial, should it ever happen, 0 factorial by definition is equal to 1. For it to work in our formulas, it has to be equal to 1, and again, that is written in your book. But what we have here is we have 4 times 3 times 2 times 1, and on the bottom we have 3 times 2 times 1, and then another 1. And notice again that the 3 2 1s go away, and so the number of ways that I can choose 3 people out of 4, there's only 4 ways to do that. 7 choose 3 would be 7 factorial over 3 factorial 4 factorial. And so if we have, oh, we have something strange, we erase it. And then we say 7, 6, 5, 4, 3, 2, 1. And I can stop writing at 4. I'm not going to put all my dots in there because I'm lazy. But everything from 4 on down is gone from here. Notice that 3 times 2 is 6, so the 6 will go away with the 6 on the top. On the top I have a 35, on the bottom I have a 1. So 4 women, 3 men in a group, and I'm going to send 3 of them to a conference. And the way, the probability that all 3 of them would be women, if I just drew randomly 3 names out of a hat, would be 4 out of 25. Sorry, 35. What I've written, not what I said. Maybe I want to find the probability that all 3 of them would be men. Now, in all of these problems on the bottom is going to be 7, choose 3. Okay, the number of ways that I can choose 3 people is going to be 35. It's not going to change in this example here, no matter how I adjust what I ask. Okay, the way that we would get 3 men is out of the 3 men that we have, we would have to choose all 3 of them. There's only one way to do that. So that probability would be 1 in 35. Maybe I want to find the probability that we will send 1 man and 2 women to this conference. So our probability or our counting rules from the last section said if I want to, from the 3 men that I have, choose 1 of them, okay, there's going to be 3 ways I can do that. 3 choose 1 is going to be 3. And if I have 4 women and I want to choose 2 of them, 4 choose 2 if I work out that, or I found the button hopefully on my calculator, that'll be 6. And if I have 3 ways of doing this and 6 ways of doing that, then altogether we multiply. That was like when we were picking a letter and then a number for our code, or we were picking a vowel and a consonant for something. We take how many of these times how many of those, and we'll get all the possible ways we can do that. So again, 3, choose 1 is 3, 4, choose 2 is 6, so that probability will be 18 out of 35. Okay, go ahead at your desk. I'm going to shrink this down just a touch, or like a whole lot. I don't know why it's done that to me. Maybe I want to find the probability that I send 2 men and 1 woman. Okay. Using your counting rules, using the above examples as an example, go ahead and pause the video and see what you can come up with, and leave your answer as a fraction in lowest terms. Okay, when you turn it back on, the answer will be there, so don't pause or don't turn it back on until you're ready to see. All right, sorry for the extra squiggle right there. My pen had a little stutter. But from the 3 men in our company, we're choosing 2 of them. From the 4 women, we're choosing 1 of them, and we take the product of those to find out how many total ways we can get 2 men and 1 woman from that group, okay, out of the 35 that we had. In the next video, I have another 2 or 3 examples like this set up. I'm going to go ahead and stop this video here and put them in their own, and so we'll do some more of these next time.